I'm Andrew Davies. I'm an Associate Professor of Ecology at Harvard University and the Chief Scientist at Earth-Eco. So biodiversity capacity is a metric that we're developing to try and reliably simplify all of these measures of biodiversity into a way that is relatively simple, scalable, easy to measure, and transferable across ecosystems. And the way that we're doing that is thinking about one of the key drivers of biodiversity in any ecosystem is what we call ecological niche space. So the more niches or niches, depending on how you want to say it, available means the more species can exist in these individual niches. And so the more of that we create, generally the more species we have. And so the way we're doing it with biodiversity capacity is measuring the structure of an ecosystem. In terms of structure, we mean normally or primarily vegetation structure. So it's 3D structure in terms of how tall is the vegetation, how much horizontal cover or lack of cover is there, how many branches are there, what's the three-dimensional structure of vegetation. And there's a lot of ecological theory to suggest that the more heterogeneous the structure is, the more ecological niches there are. And so there are showing relationships between increased structure or complexity or heterogeneity leads to increased species richness. And that's been shown for birds, for plants, for a whole range of different taxa. And so biodiversity capacity is using structure, 3D structure, to predict the capacity of an ecosystem to harbor biodiversity. So the more structurally complex, the more diversity it should hold. And so this is a way of having the same measurement across ecosystems with the same understanding that increased complexity leads to increased diversity. Now, it's not all that straightforward because there are things that come into it like productivity, disturbance, all of these things that alter those relationships, which is why the relationship between structure and diversity in a tropical rainforest will be different to what it is in a grassland, for example. The premise is the same, but the degree and the scale and the sort of slope of that relationship will differ. And so what we want to do is create a metric of biodiversity capacity for every ecoregion on the planet. So the way we're developing the measurement is using LiDAR data. So LiDAR is a sense for light detection and ranging. It uses laser light to bounce light from the sensor to the target or the ground and back up to the sensor, which then measures the 3D structure. It's kind of very much like radar, but it uses light instead of radio waves. So we use LiDAR data to measure very fine-scale 3D structure of ecosystems. We then combine that with measurements of biodiversity from field experts in terms of birds or insects or plants. We combine it with acoustic measures as well to measure acoustic diversity or different species as well. We relate that to structure and build all these models. We'll take the LiDAR measurements and we'll understand what we need from satellite to scale these out. And then we'll use the relationships we know between structure and diversity to predict biodiversity without needing the biodiversity measurements on the ground. But then what we will do is still do these biodiversity measurements as an audit or ground validation of the predictable, how the accuracy of our predictive models. But the idea is to build these relationships with high resolution LiDAR and biodiversity, scale them to satellites, then use satellite-derived measures of biodiversity capacity to predict biodiversity without having to do these ground measurements. That's what biodiversity capacity will be. So a lot of people are excited about this metric because I think what it does is it's scalable. So we can predict biodiversity across large regions without having to do all of the sampling at unique places. It's holistic. We're not just thinking about the number of elephants. We're thinking about biodiversity generally and how it correlates or scales with structure. And I think it's scientifically robust. It's based on a lot of ecological theory. That dates back decades, looking at these relationships between structure and diversity. So currently a lot of these measurements rely on a lot of intense fieldwork, basically just sampling biodiversity without really trying to link it to anything beyond what the observations that they're finding. It's very static in time. It's one measurement at that point. It's selective. It's only looking at certain groups. A lot of times it's focusing on species that are cherry-picked or endangered species, which is a very small part of biodiversity. Whereas biodiversity capacity is agnostic to species or taxa and thinking about these relationships more broadly. It doesn't matter if it's insects or birds or plants, it's actually all of the above. It's trying to get at all of them in a way that's scalable and consistent across these different regions. But I'm excited about it for all the same reasons. I think a lot of these biodiversity metrics are very tailored towards specific groups of organisms, and I think we need to move away from that. And we need to value biodiversity as biodiversity rather than the number of wattled cranes you have is important, but that's not biodiversity. That's the number of wattled cranes. Biodiversity is the number of species of Earth and how many of them there are. That all comes together to understand the biodiversity of these ecosystems, and we can use biodiversity capacity to get at that in a way that is holistic, scalable, and uses ecological theory in a consistent manner. I think it's a good idea because I don't see many comparable things. Like when I look at the market, and I don't look at all of them, but most of them are these kind of cherry picking. It's about doing these surveys and identifying one species or one group and focusing all of that. I don't see a lot of holistic measures out there. There's a lot of holistic measures of biodiversity. That's different. Like the science of biodiversity is different, but trying to turn it into something that is marketable and usable in this kind of way, I don't really see that. I mean, I think there's a lot of people holistically measure biodiversity. I don't want to be misheard there. But the way we're using biodiversity capacity, I think, is unique in this space. We've been measuring biodiversity in holistic ways for a long time. And that's what we're taking advantage of. There's a lot of indices of biodiversity that consider number of species, the abundance, the evenness of the species. There's plenty of those. I think what I don't see is the application of these holistic measures of biodiversity in this market-driven approach to how can we holistically, scalably measure biodiversity in a way that is simplistic enough to do a good job without getting caught up in too many of the details. And that, I think, is unique in biodiversity capacity that I don't see in many other metrics that are trying to achieve the same goal. The premise is going to be the same across ecosystems, but the relationships are going to differ. And so to make it comparable and scalable, we need to do a lot of work to establish those relationships within individual ecosystems. To understand in this ecoregion, this is the relationship between structure and diversity that we can model, and then we can then predict how much biodiversity one ecosystem should hold, which is the capacity. Structure, complexity, and diversity will be the same, but it probably won't be a simple linear relationship, but assume for now that it is a linear relationship. The slope of that line will vary. So in a place that's highly productive, like tropical forest, you'd expect it to actually probably be steeper, because the more productive it is, generally, perhaps the more species it could harbor, and therefore if you increase structure, you're getting a sort of better return on your investment, if you will. Productivity can be measured in vegetation biomass, these kinds of things that is kind of a product of rainfall that you get, solar insolation, temperature, all these kinds of things that make an ecosystem productive. And productive is to produce biomass of vegetation or animals or combination. So like salt, I mean, this is complicated, but like salt marshes are extremely productive but very low in diversity for lots of various reasons. Like this is why this all kind of breaks down at some point. But the general premise is that within a salt marsh, a more structurally diverse salt marsh, more structurally complex salt marsh will be more diverse than a simple salt marsh. But a salt marsh may be structurally simple compared to tropical rainforests, well, that's a bad example, or temperate rainforests, but have high diversity. But within these ecosystems, you'd expect these relationships to hold. Some ecosystems will be able to hold more biodiversity than others due to these other factors, like productivity is one, stability time, how long are they stable for. Stable ecosystems tend to have more species, which is why the tropics are more diverse than the temperate regions, or one of the policies. There's a lot we still don't understand about the drivers of biodiversity, let's put it that way, or it's more complicated. It's not a one-size-fits-all. And some ecosystems will be able to have more species than others, which is why in a New England tropical forest we have fewer species than the Amazon. No matter, even if you have the same structural complexity. Oftentimes you won't. like tropical rainforest would be more structurally complex than temperate forest, but there's more to it that's going on. And so the ceiling of that capacity could be higher in the tropical rainforest than temperate forest, but you still, within that region of space, you still have this relationship to destruction of this.